Welcome to today's episode of SciTech Discoveries and Inventions. Please feel free to turn your captions on.
We all know that the sun's magnetic activity fluctuates over a broad range of timescales, spanning from minutes to thousands of years and beyond. Sunspots have always piqued the curiosity of space researchers. By definition, sunspots are dark regions on the solar surface with heightened magnetic activity. Interestingly, sunspots appear, grow, and disappear over time. This cyclical pattern of sunspot activity, also known as the sunspot cycle, repeats approximately every 11 years. Space physicists from the Indian Institutes of Science Education and Research have predicted a peak for the 25th solar cycle in 2024. What does this mean for us? It means that next year we need to take extra steps to prevent the disruption of satellite operations, radio communications, and power grids. On the positive side, gigantic auroras are very likely to be visible during the peak of the 25th solar cycle. Of course, when I say 25th solar cycle, I mean that we have only been able to study and record 24 such events so far. On January 1st, 1995, a 26-meter-tall rogue wave caught everyone off guard before slamming into a Norwegian oil platform. Rogue waves, also known as monster or killer waves, are unusually large waves that form in seas and oceans. They exhibit distinctive features such as atypical height, high speed, and steepness, setting them apart from surrounding waves. These extraordinary waves pose a significant threat to ships and offshore structures. They can form and emerge without sufficient warning, even in seemingly calm seas and oceans, possibly due to the constructive interference of smaller waves. However, the precise mechanism governing the formation of rogue waves remains largely unknown. A research team has recently used artificial intelligence to forecast rogue waves by analyzing 700 years' worth of data, marking a significant advancement in wave prediction technology. This is a major scientific breakthrough. Considering the potential damage rogue waves can inflict on ships and oil rigs. Speaking of predictions, did you know that Google is taking weather forecasting to the next level with the help of machine learning? Google's GraphCast employs machine learning and trains itself using reanalysis data or weather-related data from the past. Thanks to this approach, GraphCast can predict hundreds of global weather variables covering a 10-day period within 60 seconds. While Google's GraphCast does have certain technical limitations, it proves to be more efficient in tracking tropical cyclones and extreme temperatures than existing weather prediction models. Researchers from Google and Princeton University are employing a new approach to create robots that are smarter than ever before. Imagine the situation. There's a table with multiple dissimilar toy cars, each painted with a different color. You ask a robot to pick a toy car. In such a scenario, the robot should ideally ask the user a question or a series of questions that will help it choose the correct toy car. Guess what? Engineers are precisely adopting this approach and using large language models to revolutionize the field of robotics. However, trained robots are being programmed to ask a question only when the options meet a certain probability threshold. For instance, the robot does not ask a question when tasked with picking a red apple from a group of red and green apples because there is no uncertainty involved. Meanwhile, let's wait and see what happens when the Google-trained robot is tasked with picking a girlfriend or boyfriend for a date. Of course, that was a joke. We all know that plants do not have eyes. But then, how do they determine the direction of light? Well, plant tissues harbor smart photoreceptors that respond to light, aiding the plant in decision-making. This phenomenon is known as phototropism. For instance, whereas plant stems typically exhibit positive phototropism by growing towards the light source, plant roots tend to display the opposite, or negative phototropism, by moving away from the source of light. Although biologists were aware of this phenomenon, the underlying mechanism had remained elusive for years. A team of brilliant scientists has finally decoded the underlying mechanism of phototropism. Long story short, air-filled channels inside plant tissues facilitate the process of phototropism. Quite interesting, isn't it? quite recently, something truly remarkable happened in Siaka, a town in southern Italy. Nearly 80 years ago, a B-25 bomber had crashed in this town during World War II. A team of investigators, led by forensic researchers from Cranfield University, conducted a careful investigation in Italy. In October 2023, the team performed extensive DNA analysis and announced the discovery of human remains belonging to Gilbert Haldeen Myers, almost 8 decades after the airplane crash. Myers was co-piloting the B-25 bomber when it crashed in the Italian town of Siaka. By the way, did you know that DNA-based forensic investigations have resolved numerous mysteries in the recent past? Have you ever been to the Yellowstone National Park, located in the U.S. state of Wyoming? You will be surprised to know that there are geological hazards lurking below Yellowstone. Using LiDAR, or light detection and ranging technology, researchers created detailed maps of the terrain beneath the dense forests and foliage of Yellowstone. By doing this, they gained insights into the prehistoric landslides and earthquakes that tormented this region long time back. By studying these historic geological events, scientists are gaining a better understanding of the current risks faced by the millions of people residing in the vicinity of Yellowstone.
Enjoyed watching this video? Subscribe to SciTech Vault for research that matters.